Hello, my dear electrical professionals. Today we'll discuss on single line diagram of a substation. How I can represent the substation in the single line diagram. The single line diagram, in short it is called as SLD, is most fundamental engineering drawing in substation design. When we'll go to design the substation, first we have to draw the SLD or single line diagram of the substation. It represents the entire electrical system using a simplified one-line format instead of showing all three phases. The lines are supplied in three phases, but the three phases are not shown in the figure and the drawing. Is only one line. It is represented by a single line. So while drawing a single line diagram, standard circuit symbols are also used. Circuit symbols for the components of the substation. Then these are the most important circuit symbols. Electrical symbols legend. Here the transformer, circuit breaker, and load as motor. This is the busbar, this connection switch. This is symbol for fuse switch. This is the symbol for earth or ground. This is the symbol for current transformer, and this is also symbol for voltage transformer. This is the symbol for overcurrent relay. This is the symbol for protection relay, and this is the meter, symbol of meter, and this is the symbol of lightning arrestor, and finally this is the representation of earthing or grounding of the system. In single line diagram, the line diagrams consist of the following components. One is your incoming line. This is the supply source from the transmission network, where it is the power is coming into the substation as the incomer, and is usually from the grid substation and other feeder. Similarly, secondly, lightning arrestor. Then it is a lightning arrestor. It protects the equipments from overvoltage surges due to the lightning caused by lightning, and it is installed at the line entry point. When the incomer is at the incomer point, the lightning arrestor is installed. Similarly, then we come to isolator. The isolator disconnector, it is used for no load isolation. Where it is isolated, there is no load. It ensures the visible disconnection for the maintenance. This disconnection or isolation is carried out for electrical or maintenance. It is always operated without load. When the system is isolated from power by circuit breaker, then the isolator becomes without load. At that time, it is operated to keep it in isolated form. So the each then earth switch, it is connected to the isolator. It is connected to the isolator, earth switch. Here, then the current transformer, then the current transformer, where then it steps down the current to the measurable value. Suppose say if our system is 1000 ampere, it reduces or transform to 5 ampere through the CT, so that it will be in the measurable form, can be measured easily. It is used for metering and protection release. This CT is also used for protection of the system and also as used as metering as energy meter. Then potential transformer. This is called potential transformer or capacity voltage transformer. Capacity voltage transformer is this is available in higher voltage substations. It steps down the voltage from 33 kV to 110 volt as standard, or it may be 100 volt, and is used for voltage measurement and protection schemes. So CT-PT are used for protection schemes and metering also. Then come to your circuit breaker. It is the most protection critical device. It interrupts fault current automatically. There are different types: VCB, ACB, and SCB. Vacuum circuit breaker. It may be air circuit breaker or sulfur hexafluoride, that is gas insulated breaker. Then we'll come to your bus bar. The bus bar, it is a common electrical load where multiple circuits are connected. What is bus bar? The bus bar is a common electrical load where the multiple circuits are connected, and these bus bar arrangements may be single bus, double bus, or ring bus. One and a half bus bar scheme are there, but it is applicable for ESB substations. Then power transformer. Here is the power transformer. It steps down the voltage from 33 kV to 11 kV. For example, its key rating is MVA capacity. The rating of the transformer kVA or MVA capacity, impedance and cooling. Impedance in ohm and cooling. Cooling may be all natural, air natural, or oil natural or air forced. ONAN and ONAF. Then 11 kV bus. Here the 11 kV bus bar. It distributes the power to the multiple outgoing feeders. These are the outgoing feeders. These are the outgoing feeders through circuit breaker and feeder circuit. And this distribution transformer, it supplies the electrical power to the industrial loads, distribution transformers, and residential areas. Then I shall display you some single line diagrams of the substations. Here you see it is a simple single line diagram of a substation. Here everything is displayed. The loads are in motor form here. Here in specifically you have displayed the single line diagram of the 33 kV substation with single bus bar scheme, only single bus bar scheme. Here there are two incomers, 33 kV line 1 and line 2 through LA. Then your isolator is there, CT and circuit breaker, PT, and these are the 33 kV single bus bar. From these outgoing feeders are gone through circuit breaker, current transformer, and disconnector. Here is LA. Here the same 33 kV is fed to other substations. Same feeder, 33 kV feeder. Here through transformer it is converted into 11 kV outgoing feeders to distribution. Here is capacitor bank is connected. Bus sectionalizer. Bus a single bus is sectionalized. We can isolate one bus section. These are the station service transformer. Through this, the substation auxiliary power is fed. So these are the single line diagram for 33 kV substation. Here transformer, relay is here, mutual relay, OLTC, on load tap changer here. Through the capacitor bank, the power factor improvement is done here by capacitor bank. So these are the single line diagram of 33 kV single bus bar scheme. Here is another diagram. 30 kV incoming line through LA, CT, isolator, PT, then the circuit breaker here through ये 33 by 11 kV transformer distribution transformer here. Here the bus coupler, the double bus is there. Here the bus coupler. Two buses are connected through circuit breaker, bus coupler circuit breaker. So these are the one of the diagram for 33 kV single line diagram for double bus. So these are all about the single line diagram of the substation. As the single line diagram of all other substation can be in similar way, but our focus is only on 33 kV and 11 kV substations, and on that we'll discuss every factors of these substations in depth in our incoming classes. Then these are the discussion for today. Next we'll take up another class. We'll discuss successive topics. Thank you.